What's up, guys? Welcome to your 7th Java game applet tutorial where we're going to work with our ball. It's looking pretty good right now. We got our our Y direction all sorted out. Now what we're going to work with is the horizontal direction, adding some friction to our ball when it hits the ground to make it look a little bit more realistic. So we're just going to jump into our run method again, and just to show you guys what I mean, what we're going to be doing. Let's set our dx value to be 20, something like that, and run it. Now our Y is still working, but our ball will roll forever. So we want to get rid of that problem. So what we're going to add is some friction when it hits the ground and all that stuff. So let's scroll down again to a run method. We're going to throw in an if statement above where we set up our Y positioning, and we're going to say if Y is equal to this dot get height minus radius minus 1. So if it's at the bottom of the applet, we're going to deduct some horizontal direction, kind of like we did with when we had the ball bounce. This time we're just going to kind of slow the ball down every time it hits the ground, or if it starts rolling, it's going to gradually slow down as well. So again, all we're saying right now is if our ball is at the bottom of our applet, we're going to say our dx, again that's referring to the x speed, and we're going to say times equal, we could either say our energy lost or some kind of value. Generally you'd want for this example our frictional, or we're going to say our x friction and set that up. We want our x friction to be less than our energy loss that we set up when it bounces. So we set up something called x friction. Let's just go up here and create a new double for our friction in the x direction, and we're going to set this equal to be like 0.9 instead of 0.65 like our energy loss. So we're just going to run this with our values that we have set up here, and each time it hits the ground it kind of slows down by 90%, and right here it looks a little bit kind of shady. It doesn't seem like it's stopping at all, but eventually it will right there. So all we're going to do to fix that is again scroll down to where we were just working, where we check for the height, and we slowed down our x speed by our friction component. And then what we're going to do is we're going to say if like our dx is less than, let's say, like 0.5, or we could do like 0.8. What we're going to do is we're just going to set our dx to be equal to 0. We're just going to help slow down the process a little bit quicker. The only problem is, well, let me show you, because if I don't show you, some of you guys will probably be confused about this this concept here. So right now, as you can see, our x position just stopped the first time it hit, because when it's going backwards our dx is a negative value, which is obviously less than 1, and that's not what we were trying to that's not what we were trying to do. So all we're going to do is we're going to say the absolute value of our dx. So again, if you guys watched the previous series, we remember the math class has an absolute value method in there. So we're just going to say the absolute value of dx. So whether it be negative 18, it's just going to compare 18. Is that less than 0.8? Well, obviously not. So now it should get rid of that problem, and let's check it out. Looks pretty fancy and pretty good, and it slows and stops a little bit quicker than it did previously. So again, thanks for watching, guys, and I'll catch you in the next tutorial. Have a good one.